Hey, hi everyone. So today we are going to look at a very interesting problem that gets asked a lot in interviews. The problem statement is called merge two sorted list. So we'll have two lists. Let's say list one equal to something like this: 1, 3, 5, 7. We can see that these list elements are in sorted order, in ascending order. And let's say we have another list something like this, 2, 4, 6, 8, and we can see that this is also in sorted order. So now the problem statement is we should get an output which is something like this. We have 1, 2, 3, 4, 5, 6, 7, 8, and you can see here all the elements on list 1 and list 2 are combined, right, and you got an output rated. So that is the merging part. Now we can think of many solutions for this, but one key requirement is there should be no extra space created, which means that we should kind of append to either list 1 or list 2 when we figure out which is the element should go in where, right? And another requirement is the length of arrays could vary. So currently we have in this one the length is basically 4. We have here the length being 4, right, which is good. But there could be cases where the length of array is, let's say, maybe 100, and here we have length of maybe 2. So it should work for all the cases. The other thing is this is all going to be integers, right? So there's not going to be decimals. All the numbers will be integers. Okay, so with that in place, let's think of maybe how we can actually approach this. So one way to think of is basically we need to mutate one of the list, right? Either it's list 1 or list 2, we have to mutate. Now when we are mutating, we can if you're mutating, then we need to keep some kind of a pointer. So let's say we have a pointer for the list 1. Likewise, we should have a pointer to the index of the second element. So then let's say basically when we are creating this final list, 2 is basically going into the position of where 3 was earlier, right? So basically the checking here is we are checking whether the index pointer is greater than, that is this index. When the index pointer comes here, we are checking whether that index pointer is greater than the index pointer pointed to the element in the list. If so, we are basically doing a swap. Not a swap, we are inserting at that point, right? So the other thing is, when let's say it's not greater, what we are doing is we are just going to keep on incrementing the index 1 pointer to the list 1. Yep, so that's the basic funda. So let's try to write some code for doing it. Yeah, I'm going to use black. Okay, so let's define a function, merge to list, which will take to list 1 comma list 2, right? Okay, and I'm going to have two variables to store the pointers to index, int1 and int2, and I'm going to start obviously from 0. So I'm going to have some mechanism to iterate over the both the list 1 and list 2, and the iteration should stop when, let's say, one of the indexes, one of the list I have completely iterated over, right? So I'm going to use a while loop for doing it. I'm going to say while int1 is lesser than len of list 1, okay, and int2 is lesser than len of list 2. Okay, so this is my terminating condition. If one of these guys fails, then basically I will come out of this while loop, right? Let's say one list has been completely iterated, I want to exit out. Okay, now what can I do? I will have my if condition where I will check if list1 of index 1 is greater than list2 of index 2, right? If it is greater, just like the case that we had here, 3 is greater than 2, then what we are doing is we are putting 2 in the place of the index pointing to the list 1, right? So we will do list1 dot insert, and where are we inserting? We have to index it, insert it at the position of the int1, right? The pointer being int1, and the value that we are inserting is nothing but list2 of int2, right? And at the same time, in this case, since we are actually inserting, we have to move both the pointers. So I'm going to move int1 plus equal to 1, and I'm going to move int2 as well as. So there's an else clause to it, which is that this is not greater, right? Let's say the pointers are initially at 1 and 2. Obviously it is not greater. In that case, the only index pointer that I had to move is basically the int1. I should move int1 to plus 1, right? So here I will do int1 plus equal to 1. Now at some point, once this while loop breaks out, we'll have a condition where, let's say, the smaller array, the list1 has been probably completed. We have finished iterating over it, but there are still elements of list2 that is still present, right? So in that case, what we have to do is we have to just extend list1 with all the elements that are remaining in list2. So how can we check that? We can check it by saying that if if int2 is lesser than len of list2, then basically we have to do list1 dot extend list2, and we should start from index 2, right? And that is basically the program. We finally return list1. So just to go over some fundas here again. So we have the index pointers initialized into zeros. That's the first point. We have 2 pointers for both the list. We have an exit condition which would actually terminate, let's say, if we have completely traversed one of the list, either int1 or list1 or list2. Because it is an AND, we will break out if we had finished traversing for one of those. The funda there is like if you have finished, let's say, list1, and then what we can do is like we can just extend whatever is remaining like this at the end from list2, right? So when do we actually insert this point? Let's say we figured out that the current element pointed in list1 is greater than the current element pointed by list2. Then we insert in list1 at index 1 pointer the element in list2, and then we are incrementing both index 1 as well as index 2, right? Because we want to move both in the forward direction. The other case is it is actually not greater but lesser, right? So in the case it is lesser, then we basically want to just actually move the one of the index element by 1. That's the program, and thank you for watching.